Okay, welcome back, and Merry Christmas to everyone who celebrates it. Been a little while. Sorry about the lack of videos. Been quite busy with life and that. But anyway, we're back, and what we're going to do today, we're going to add some improvements to the parser, and we're going to add in our main bit, we're going to add an evaluator so we can actually start calculating some bits. And yeah, so what we've done already, we've done the Lexa, that was in episode 1, and last episode we did this parser. So basically it's called a recursive descent parser, and it'll just basically go through our list of tokens, see what kind of type it is. So for now we're only handling plus or minus. Then it will find the next token, pass, and then it will call this function. Basically just does a load of work, and just goes through all the tokens and constructs our abstract syntax tree, which comes from here. So then we create left token, and then left tokens brought back in, and it just sort of recurses. So if we do, if we just do main, and we can see what's going on. So so you can see this is our syntax tree. If we do a bit more of a complicated one, so we got 1 plus 2, and then we got the result of that, and then plus 3. So sort of doing like that. Now there's a few changes I want to make. The first thing we're going to do is go to main, and then we'll create a new branch. Let's call this episode 3, and we'll call this evaluator. So first thing I want to do is, we don't have any real types, or for tokens we don't really have a class, so I want to create some syntax. Actually no, we'll call this expression. Should we call this expression types? Let's do this for now. So we'll do a class, and we'll call it what should we call it? Call it syntax node. And then basically we want this to be sort of an abstract syntax class, an abstract base class. So we don't want to instantiate this. Basically we just want to use this as something that we can inherit from. So let's do this. Something like this. Just do like that. Okay, cool. Am I being an idiot here? Okay, fine. So that's cool. So now what we want is, we want a binary expression. Cool. So when we construct binary expression, we're going to have the left token, the right token, we're going to have an operator token. So what we're going to do, just call this left token, operator token, right token, and then we'll just inherit from syntax node, and then we'll do this dot left token equals left token, this dot operator, and then this dot right token. Cool. So now let's export these. Okay, nice. So now if we head over to our parser, first things first, let's import these, because we're probably going to want to use these. it expression type? Is that what we call it? Okay, cool. Right, so how do we want to do this? I think we're probably going to refactor this a little bit. Cause I've been messing around with some bits like offline from the series, and I don't know. There's some bits we can definitely improve. Okay. I'm just trying to think. So when we have currently all we've got is plus and minus operations, but obviously we're going to want to have multiply, divide, and in maths you've got the order of operations, which basically tells you what order to perform the operations in. So we want to be able to account for that. So let's make a quick function called get operator priority, and this function is a private function, and it's going to take in token type. So now we'll do a switch statement. So we've got times. What? I might open this to the side. So we've got times token and divide token. So times token, divide token, they're going to have a higher precedence than additional subtraction. So let's do divide token. And then what we'll do is we'll return, let's do 2. So we'll just return an integer, and then we'll do, for the other cases, plus and minus. Minus token. We'll return 1. And then the default will just return 0. Okay, that looks fine. So yeah, so this basically will just handle the order of operations, and so we're going to need to obviously call this function. Now I think we'll rewrite this function, so parse will just comment that out for now, and we'll replace it with this parse expression function, and this will handle the priorities. So what we were actually going to put into this is we're going to put into the priority of the parent token, or the priority of the parent operator, priority, and we'll just initialize that to 0, because that's what we've chosen as our default. So we'll do constant. Actually, no, we want that. Let left token, and we want to pass binary expression. So that'll get us started. And now while true, we can get rid of this now. Don't need that. So what do we want to do? We want to do let priority equal this dot current token dot this dot current token dot kind. So we're going to get the priority of the current token, and we basically want to check if the priority of the current token is less than the parent priority. So if priority, let's do priority is 0, or I've been programming on my Mac too much. Priority less than or equal to parent priority, and our parent priority we've initialized here. Then we're going to break. Otherwise, we're going to let operator token be the next token, and right token is going to be this function again. So we're going to recurse, and then yeah, okay, that makes sense. This dot parse expression. where is it? I can't see, there it is. And then for the priority, we're going to pass in our current priority. So that's what we're getting here. Cool. And now our left token is now we can use our binary expression we just imported. So we'll do a new binary expression. And we'll do left token, operator token, and right token. And then what we want to do is we want to return left token at the very end. Okay, that looks good. So this parse binary expression, I think we need to. No, that's okay. That's okay for now, I think. Okay. Cool. So now this parse function, what we can do, we can actually uncomment it now. We just want to modify it a bit because it's not quite right. We just want to do let abstract syntax tree equal this dot parse expression, and then we just want to return it. So we can actually just do return this dot parse expression. And this actually, let's make this private, because then all we want to expose is this parse method. So let's check, see if this is still working. Still working, but our this function is going to be broken because we're now we're using our custom class here. So I think the way that we'll fix this is we'll just console log JSON stringify AST, and then is it null? Only 4 spaces. So let's try that again. Maybe it should be that. Okay, there we go. Fuck's sake. Oops. 1 plus 2 minus 3. Okay, fine. Right, so this this is why you use a type system, because that should have been token type and it was kind. So this is why you don't follow your notes, and this is why you actually read the code. It's also why you don't take like 2 months off from making YouTube videos, because this type of things tends to happen. Okay, so our thing's fine now. Printing our abstract syntax tree fine. You can see we've got 1 plus 2. So that's fine. Now what we're going to do is we are handling this. So if we do, sorry, it's been so long since I've done this. So if we do 1/2, we do get divide token. Okay, fine, cool. So what we're going to do now is we're going to do an evaluator. So this is going to actually basically process this syntax tree that we've got here. And basically calculate the result of any operations in it. So call this evaluator. And what do we want to do? So we don't want to pass in anything in the constructor. I think the way that we'll do this is we'll define this operations. So yeah, I think this is probably the easiest way. So we'll make an object called operations, and basically this is just going to contain all of our operations that we can do. So we'll just start with plus and minus for now. and then we'll just define these as little callback functions. Okay, should probably put a comma there. So yeah, so basically when it sees plus, it's going to do left plus right, and just this is just a callback function, and then same for there. And basically we just got these in a map, so we can quite easily access them. So that's our constructor. Now we're going to want a function called evaluate, and this is where we're going to pass in the abstract syntax tree. So what we might want to do, we might want to import our binary expression. Expression types. Is that cool? Okay, nice. Yeah, so what we want to do, if AST is, if we do is instance binary expression, why is it? Oh, it's instance of, I'm thinking of Python, man. Instance of, there we go. God, too much Python. That's what it does to your brain. Then we'll call const left equals this dot evaluate. So we're going to basically recursively go through the tree. And basically we're going to pass the, not node, am I reading? This dot evaluate AST dot left token. So we're going to go through the tree, and then basically, because when we're passing in AST, we're just passing in this massive thing, so we need somewhere to start. So we're going to start with the left token. We'll get the right token as well. This dot evaluate right token, and then const, let's call this operator equals it's AST dot operator token dot value. Is it token value? God, it'd be really good if like type safety, wouldn't it? Token value, yeah, it is. So token value. Okay, so that's good. And then now we want to do if, basically we want to check if the operator is valid, otherwise we can throw an error. So if this dot operations, and then we want to do operator. So basically if it's in our little map that we've got here, then we can continue, and then we'll just return basically we want to return this function, we want to return the output of this function, and the parameters for this function are left and right here. So we'll do return this dot operations operator, and then we'll pass in left and right, and then we'll just throw an error otherwise. So we'll just say unsupported operator, and actually I'll use some backticks so we can get some nice formatting. Operator. Cool. There's one more case that we want to consider for now. This is obviously very simple, but we also, if for example you open node and you just do a number, it just prints a number back to you. So it might be quite nice if we do that. So if we do where should we do this? Oops. If we do else if, and then we'll do AST dot token. What is it? Is it token kind? Token type. Token type number. Then we'll just return Let's do return parse float ast.token value. And then otherwise we'll just throw an error like something. So say we're passing in an invalid structure in the abstract syntax tree, then we'll just throw an error. And again I'll use backticks. I'll close that unspooled syntax node. We'll do ast.token type. Cool. So that looks fine. There's probably going to be 20 bugs in it, but for now let's give it a try. So we'll do let evaluator equal new evaluator. We'll do let result equal evaluate.evaluate, and we'll pass in the AST. See what happens. So something happened. Don't think it was quite right. Oh, it would help if we log the result, wouldn't it? And there we go. So let me just hide this because we don't really need this for now. 1 plus 2. 1 plus 2 does in fact equal 3. And I don't know why this is still... Oh, this is probably from when I was debugging, wasn't it? Yeah, let's get rid of this. Try this one more time. 1 plus 2 does in fact equal 3. So there we go. Let's try some more stuff. So let's do 1 plus 2 minus 3 equals 0. 1 plus 2... did we hand... We don't have multiplication yet. Let's quickly add multiplication. So we'll do star here. So it's exactly the same logic, just multiplied. And then divide, we'll do as well. So let's do 1 times 3 does in fact equal 3. Let's do 1 plus 2 times 3, and that equals 7. So I think if we hadn't implemented this logic here, this probably would have given us 9, because what we would have done is we would have done 1 plus 2 equals 3, and then it would have multiplied that by 3. So you see how the order of operations is important here, because in the UK we say bid mass, so it's bid mass, and that's I'll do a different, do this multi-line. So B is brackets, I is indices, so powers, D division, M multiplication, and A addition, S subtraction. So it should always go in this order. So it should always work out stuff in brackets, and then it'll go indices, division, blah blah blah. And that's basically what we've done here. So division and multiplication, they're returning 2 for the priority, and then plus minus tokens will do 1. So that's nice. That's working. And then if we do, I know at the beginning we said we're going to deal with just integers, but the parse float sort of works. In JavaScript doesn't really have any distinction between integers and floats, so we'll just let's just call them numbers like JavaScript does. So yeah, so we've got our basically the world's most advanced calculator. So yeah, I think that's quite a lot to take in for one episode, and this code's a bit of a mess, so I might do another episode where we tidy up all the code, but for now we've got our evaluator working. Would like to start doing some unit tests, because we're starting to get to the size of this where it might be nice to be able to just make sure that we're not breaking anything whenever we make some changes. I'm just going to move the evaluator to a new file. if it works. I don't know why this isn't working. Move to a new file. Okay, fine. So yeah, let's just tidy up this a bit. Evaluator.js, and then we'll do we'll just import it up here. Cool, and this needs to go in here. So it actually knows what's going on. Just save this little comment, you know, if anyone comes back to it. Not that anyone will, but it's still there. Let's make sure it still works. 1 plus 2. 1 plus 2 is in fact 3. I don't know why it's printing that out below it. That's a bit annoying. See if we can find where it's doing that. Is that in Alexa? I think it's here. Yeah, there we go. Plus 2. Cool. And then if we just do 1 as well, or any number. Oh, that's a bug. Oh, so okay. So what if we do 0.2? Yeah, okay. It doesn't like that. Yeah. So well, it's like I said at the beginning. We do floats because we're not in our regex for number. We're not really looking for any decimals. I guess we could probably do something like that, but well, I'm not gonna mess around with it. Yeah, but that's something further down the line to do. Alexa crashes decimal. Okay, cool. So I'm going to commit this, push it up, so if anyone's interested, they can have a look. Let's say update parser. Add evaluator class. I need to sort that out. So yeah, thanks for watching. Hopefully next video won't take too long, but it probably will. And yeah, have a great Christmas, and I'll see you in the next one. Goodbye.